Good morning. Today I am going to discuss about electrochemistry, especially hydrogen as fuel. An alternating fuel must be technically feasible, easily convert to another energy form when combusted, be safe to use, and be potentially harmless to the environment. Hydrogen is the most abundant element on earth. Hydrogen is the most abundant element in the universe and is principal element in the universe and is the principal element in the solar atmosphere. The giant planets Jupiter and Saturn consist mostly of hydrogen. The key criteria for an ideal fuel are inexhaustibility, cleanliness, convenience, and independence from foreign control. For the past 40 years, environmentalists and several industrial organizations have promoted hydrogen fuel as the solution to the problems of air pollution and global warming. Similar to electricity, hydrogen is a high quality energy carrier which can be used with a high efficiency and zero or near zero emissions at the point of use. The hydrogen production is increasing by about 10% every year. As of 2005, the economic value of all hydrogen produced worldwide was about 135 billion per year. Hydrogen is primarily consumed in two non-fuel uses. First one is about 60% to produce ammonia by the Haber process for subsequent use in the fertilizer manufacturing. Second one is about 40% in refinery, chemicals and photochemical sectors. This is the schematic diagram for the hydrogen production. Sustainable hydrogen. First one is natural gas, then coal, petroleum, coke residue, nuclear, solar, wind, biomass. Then feedstocks usage in hydrogen production. Electrolysis 4%, natural gas 48%, coal 18%, oil 30%. This is the sustainable pass-through hydrogen, renewable energy, heat and biomass, then heat converted into mechanical energy, then mechanical energy into electricity, then electricity into electrolysis process, then electrolysis process into hydrogen. Similarly, heat undergoes thermolysis process by the evolution of the hydrogen. Then biomass is converted into hydrogen, then photolysis is converted into the hydrogen. Hydrogen production methods. Most methods of producing hydrogen involve splitting water into its component parts of hydrogen and oxygen. The most common method involved steam reforming of methane from natural gas, although there are several other methods. First one is steam reforming converts methane. Second one, steam electrolysis. Third one, thermochemical water splitting uses chemicals and heat in multiple steps to split water into its component parts. Then electrochemical systems use semiconducting materials to split water using only sunlight. Then hydrogen production methods. Photochemical systems use semiconducting materials to split water using only sunlight. Photobiological systems use microorganisms to split water using sunlight. Biological systems use microbes to break down a variety of biomass feedstocks into hydrogen. Thermal water splitting uses as a very high temperature to split water. Then gasification uses heat to break down biomass or coal into a gas from which pure hydrogen can be generated. Then this is the chemical hydrogen production. Sodium boron hydrate plus water molecule is converted into hydrogen plus NaBO2. Solution is non-inflammable. Reaction control via reusable catalyst. Controlled hydrogen combustion. Then no high pressures. NaBO2 is non-toxic. Recycling of NaBO2 into NaBH4 is possible. Then electrolysis process. Electrolyte composition is pure water plus 30% of the potassium hydroxide. Then electrolysis requirements for electrolysis is high pure water, electricity, efficiency 85 to 90%, hydrogen purity is greater than 99.9%. Then electrolysis of water. By providing energy from a battery, water can be dissociated into diatomic molecules of hydrogen and oxygen. This process is a good example of the application of the four thermodynamic potentials: internal energy, Helmholtz free energy, enthalpy and Gibbs free energy. The electrolysis of 1 mole of the water produces a 1 mole of the hydrogen gas and a half of the mole of the hydrogen gas in their normal diatomic forms. A detailed analysis of this process makes use of the thermodynamic potential and the first law of thermodynamics. This process is presumed to be at 298 Kelvin and atmospheric pressure. Hydrogen production, producing hydrogen from water without electrolysis. Hydrogen production by photoelectrolysis water. Then this is the photoelectrolysis mechanism. Then direct conversion method, thermal decomposition of water, thermochemical production from nuclear energy. Then solar production of hydrogen is an appealing goal. Then hydrogen from water, solar thermochemical production methods. Then copper chlorine cycle, zinc oxide dissociation mechanism, decarbonization of fossil fuels. These are the production of hydrogen fuel. Thank you.